Hello! Thanks so much to everyone involved in organizing this meeting, and especially thanks to you for tuning into this talk, despite the internet melees I'm sure we are all fighting right now. My name is Becky, I'm at CUNY's Graduate Center, and I'm here to talk about expectation in perception. So there are at least a few things we might mean when we say we expect something. One is that we're expressing a belief or a prediction about the way the future will be based on previous evidence. So for instance, I might expect to see milk when I open the fridge because I bought it yesterday and I haven't used it yet. I also might expect that NASA will reach further and further planets because of their previous successes. We might also be intending to express some kind of normative standard or a belief about the way the future ought to be. So maybe my parents expected me to become a lawyer. Maybe I expect my students to complete their assignments. Of course, either of these can conflict with our descriptive expectations. So even though I expect my students to complete their assignments, I also expect that some of them won't. But though I ultimately don't have beliefs or even explicit predictions in mind, what I do have in mind is closer to the former thing, not the normative one. So it's something along the lines of expecting something to continue to be as it has always been in the past. So for instance, an example where this is more of a, conscious belief. Each and every day that I've been alive, I've gotten really pretty good evidence that the sun has risen. And so I believe that the sun rises, or in other words, I expect that the sun will rise. Now I think something very much like this is happening in perception as well. So we know that we're sensitive to many sorts of regularities in the environment, but the question is, what do we do with those regularities? How exactly do we exploit them? So I think we form some template of the way things are perceptually. So in other words, we perceptually expect that things will be this way. The notion that expectation plays some role in or is related somehow to perception isn't a new idea. This right here is really a tiny sampling of the literature on expectation from psychology and neuroscience. On the more philosophy side, there's the incredibly influential idea of expectation in predictive coding, made most famous philosophically by Andy Clark. Now, neither of these two literatures are really quite on the sort of thing I mean by expectation in ways that I'm going to talk about shortly. But first, I want to lay out the plan of the talk. So I want to say at the start very briefly what I mean by perceptual expectation, just to make the terrain clear. Then I'm going to talk a bit about how it's related to those literatures that I just mentioned, in particular, how it's different from those. Then I'm going to go into more detail about what I take perceptual expectation to be and evidence that I have for it drawing on the psychology and neuroscience that's out there. And then last, I'm going to talk about what I think perceptual expectation does in perception, both inside and outside the lab. So there are lots of regularities in my environment. So the things around me that I can perceive, they regularly have certain perceptible properties. So it seems natural to say that we expect that if we've always perceived something as having some property or properties. So, for example, this wall outside my window has always had bricks of that shade. It's always risen at about a 15-degree angle. It's always had a skylight of that shape. So if it's always looked like this, then it seems reasonable to think that it's going to continue to look like that into the future. It's going to continue to have those properties, even when I'm not looking at it. Now, what I'm suggesting is that for perceptible features, it's not that we're thinking, that we're having a thought or a belief to the effect that it's going to continue to look this way. I'm suggesting that this expectation is actually represented by a perceptual state. So I'm defining a perceptual expectation as a perceptual state that has representational content and that functions to represent some currently unobserved state of the world. So one thing to note here is that this definition is going to be extendable beyond cases where we have already interacted with whatever it is we have the expectation about. So we can also have information to the effect that we're about to see something that we haven't seen yet, and so we can expect that too. This is, of course, because there are two ways for things to be unobserved. Either it's there and I'm not looking at it, like that wall as I focus on my computer, or it's just not there yet. And the latter is what a lot of the experimental work is about, so we'll talk a bit about that later. Before I get into what I mean specifically by these different features of perceptual expectation and the evidence for it, I want to distinguish my account from the two in the literature that I mentioned earlier. So first, there's the notion of expectation in the psychological sciences broadly. There, expectation is the term for any sort of processing that's sensitive to regularities. So, of course, this is very broad, so it can include everything from low-level visual heuristics like light comes from above, and zero crossings indicate boundaries, to high-level conscious predictions like there's going to be milk in the fridge because it's Monday and there's always milk in the fridge on Mondays. So what I have in mind is really a proper subset of these sorts of expectations. So these sorts of expectations only at a certain level, the level of perceptual representation. The other big account, of course, is the predictive coding. So the general shape of these is that perception just is inference from your prior expectations to the way the world is. So I take it that there are at least two ways to interpret what's going on in predictive coding in general. So one is that this really is full-blown, rational, inferential reasoning of the sort that we do when we predict that it's going to snow next year in Manitoba because it snowed every year in Manitoba for the last 100 years. Now, I take this to be Andy Clark's line, but I am not going to get into the exegesis for why I take that to be his line here. The real issue with taking it this way is that this is hyper-intellectualizing perception, so we shouldn't go around positing this sort of inference in perception unless it's really absolutely necessary for explanation. Because if we're doing that, then we're requiring that anything that is capable of perception has to be capable of this kind of inferential reasoning. Now, the other interpretation is that inference is kind of a stand-in for some sort of transition from one state to another that we just don't quite understand yet. So inference as a black box. Now, of course, that's pretty unobjectionable, but it leaves us with a lot of filling in to do. So if you like, you can take my view as just that sort of filling in, or at least a line on what those states are that are involved in this transition. So this paper actually is part of a larger project where I kind of attempt to say what exactly this transition is and expand on, the scope of the sorts of states that we take to be perceptual states. So a perceptual expectation is a perceptual state with representational content and that functions to represent some currently unobserved state of the world. So I'm going to take each of these three parts in turn. By separating out perceptual state from representational content, I just mean to highlight that perceptual expectations are not cognitive states, they're not beliefs. I am a representationalist about perception, but defending that is really pretty outside the scope of this talk. The point is just that positing that some perceiver has a particular perceptual expectation doesn't require us to posit that it has or even can have a belief about that same thing. So I think my dog here has perceptual expectations about the plaid blanket around him, but as far as I can tell, he has no concept of plaid. And I also certainly can't tell him anything about those properties. I can't instruct him on what to expect. Now, there is empirical reason to take these to be perceptual states as well, which I'll return to shortly. By having representational content, I mean primarily that perceptual experiences aren't representationally implicit, meaning they're not hardwired into the visual system the way we might think that the prior that zero crossings indicate boundaries is. So we can maybe describe the visual system as representing that zero crossings indicate boundaries, but it would really just be a convenient way of speaking rather than a totally accurate reflection of what's going on. I also mean to flag that perceptual expectations have accuracy conditions, so they're about the world objectively, and they can be confirmed or undermined by the way the world is. So the clearest cases of these accuracy conditions is going to be at kind of either extreme. So for example, if you cue me to expect a red square and you show me a blue triangle instead, that's pretty clearly a non-veridical and inaccurate expectation. If I perceptually expect a certain shade of bricks on that wall across the alley, if everything goes as it has been going, that is going to be veridical. Lastly, perceptual expectations represent some state of the world that's not currently observed, whether that's a future state or just something I'm not currently looking at. I want to be clear, though, it's not the content that's oriented to the future. So there is no future tense in perceptual representation the way there can be in belief. I think that would be a very serious hyper-intellectualization of perception. When I say it's functioning in this way, kind of towards the future, I really just mean that is its function. It functions in some kind of preparatory way to prepare us for what we are potentially about to see. Now for the empirical work. I suggest that perceptual expectations are what's known in psychology and neuroscience as perceptual templates. So these are decodable patterns of neural activation that are selective for the expected stimulus. And what that means is that when you expect something, your visual neurons are responding as if what you expect were already in front of you. So my claim is that perceptual templates have all these properties that I've identified of perceptual expectations. I also realize I'm covering up the citations here, so if you want a copy of the slides or a link to any of the papers, please email me or leave a comment. So first, these perceptual templates are perceptual. They're not cognitive. They're not beliefs. So they are observed in early visual areas like area V1, area V2. They're observed in the hippocampus, which has classically been taken as a memory area, but we're kind of starting to associate it more with vision. And the fusiform face area if you're expecting a face. And they aren't really decodable any higher than that. They become non-decodable fairly early on in visual processing. They also have representational content because on decoding, we can see that the visual neurons are responding very much like they do when you're actually seeing that very thing. So, insofar as perception has representational content, so do perceptual templates. They're representing the world in much the same way that vision is. And they're representing currently unobserved states. So perceptual templates are decodable at least 40 milliseconds before stimulus onset, so before the thing is even there. And they're also observed in what's called emission trials, where no stimulus appears. So what do perceptual expectations do for or to or in perception? My claim is that they actually function in the production of, they contribute content to your current perceptual state, such that what you're perceiving would be different if you hadn't had that particular expectation. So there are going to be 3 relevant scenarios in the lab. The first is when we have veridical perceptual expectations, the second is non-veridical, and the third is the absence of perceptual expectations. So a really interesting case of veridical perceptual expectations in the lab is when we expect something that's accurate of the world, but the experimenters are messing with us. They're presenting us with very abnormal scenes. So for example, subjects in Bayliss and Sinha's 2007 study at the top, they experienced scenes that were actually desaturated in the periphery, like the one on the top right. They experienced those as fully colored. And subjects in Cohen and Rubinstein's 2020 study on the bottom, they had this same experience in the middle. And on the right bottom, you can see they also experienced color-shifted or hue-rotated scenes as normally colored. So we expect that things in natural scenes are going to have their normal properties. Swimming pool water is generally blue, not bright orange. And so we perceive them as having their normal properties. When we're invalidly cued to expect a certain visual property, that affects what we perceive as well. So this is a study by Wyatt et al. In 2012, and what they found is that when you invalidly cue someone to expect, for example, a Gabor stimulus of a certain orientation, the subject is then much more likely to perceive that property in a similar but distinct stimulus. So they're inducing these non-veridical expectations and seeing that the non-veridical ones make people perceive as though that's what's actually out there objectively. Lastly, and most speculatively, is what happens when we just don't have any prior expectations. So these are Landolt shapes. I'm going to venture a guess that you do not have any prior experience with a Landolt shape with an 18-degree gap size exactly. And we know that performance that requires visual acuity, such as reporting gap size, suffers in the periphery. So why is that? My claim is that when we don't have prior expectations, all we can sort of use to represent the world is that information that our sparse peripheral cells can actually take in. So we don't have expectations to fill in the blanks, and we're left instead with something texture-like and something compressed. So for instance, this image is from Freeman and Simoncelli's 2011 Metamer model, and what they find in this model is that the periphery is just highly degraded, highly compressed compared to foveal perception. The question is, if this is what the visual system is dealing with, why don't things look like that? Under conditions that produce visual uncertainty that we know seem to be degraded, like peripheral vision, why do things look totally normal? So my claim is that this is also about perceptual expectation. Now, obviously, expectations are going to be borne out in familiar situations. When you're familiar with something, the things that you expect about it are more likely to be true. So this, again, is one that's painfully familiar to me at this point, the view from my desk at home. And it seems like our best models of peripheral vision are going to say that with only what's available as incoming information, I really shouldn't be able to perceive the detail that I do perceive of this situation, the shade of the bricks, the slope of the roof, the shape of the skylight. But I do perceive it that way. For one thing, when I look up from recording this presentation, when I'm done and I look up, I'm not going to be shocked and in awe about what I see and when I fixate on those details. The issue is that my perception of those details just can't be from representing only what's available to bottom-up vision or the incoming information, because we only have this really compressed representation. So my suggestion is that you have the compressed representation, but because this is such a familiar scene to me, I also have a ton of expectations about that building. So it's the compressed representation in combination with the expectation that gives me the perceptual state that I actually have. Now, it can't just be memory, because if I only had a memory of these properties, but I had no expectation that they would persist, that couldn't really explain it, because, I remember that the wall had those properties, but I don't expect anything about it. For all I know, it's gone. So it can't just be the memories. We need the perceptual expectation for me to bring those past points of data, those memories, to bear on what must be the case now. So the content of our current perceptual state, especially in a familiar context, it's requiring not just memories of the past, not just what's coming into our eyes, but necessarily expectations about our perceptual future. Thank you so much to everyone who has helped on this project, and thank you for your time.